All right, guys, this is 2012's AB exam number 6. It's a position, velocity, and acceleration question. You're given velocity, the equation for velocity, and you're given the particle's initial position. You're asked to find when the particle's moving left. It's going to be moving left when velocity is negative. So a number line analysis is going to be a good way to do this. You have end caps because you have a closed interval. And then cosine is equal to 0 at pi over 2 and 3 pi over 2. So 3 and 9 are the values you'd have to plug into there to get 0 out. All right, and then just plug and chug. Maybe pick a 1. The cosine of pi over 6 is positive. Maybe pick a 6. The cosine of pi is negative. And an 11 perhaps. The cosine of 11 pi over 6 is positive. So your negative sign is there. So that is when this particle is moving left. All right, part B, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time 0 to time 6. Okay, I gave you two options here. Option number 1 is integrate from 0 to 3, and then add to it the integration from, and I flipped my limits right there, because I know velocity is negative between 3 and 6. So if I flip my limits, it'll turn my answer positive. Okay? You would want to take this route right here if you were doing it by hand. If you're pushing buttons in a calculator, you could do this route right here. Okay? By making velocity be the absolute value in here, it just changes all those negative outputs to positive. So you get total distance traveled that way too. Okay? For this question, this is probably the best answer, but again, if you were doing it by hand, you'd want to take this route. All right, part C. Find the acceleration of the particle at time t. So velocity derives to acceleration. All right, so cosine derives to negative sine, and you've got a chain rule right there, times the derivative of the inner function. I just reordered it, okay? If I plug a 4 in now, because it has to find the acceleration at time 4, if I plug a 4 in for t, I get the cosine, or I get the sine of 2 pi over 3, which you can, well, the sine of pi over 3 is root 3 over 2, and so 2 pi over 3 has that same sine value. So we're here, and then I just multiplied top times top and bottom times bottom, okay? And then it asks if the speed is increasing or decreasing at time 4. And it's increasing because acceleration and velocity have the same sign there. Notice the velocity is negative at time 4 and the acceleration is negative at time 4. So particles are speeding up when acceleration and velocity have the same sign, and they're slowing down when velocity and acceleration have alternate signs. And then part D, find the position of the particle at time 4. So we have an initial condition, okay? So the position is negative 2 at time 0, and the way that you go from velocity to position is by integrating. So I'm integrating cosine of pi over 6t. I have a u method right here. I chose the shortcut. There's the derivative of the inner function. There's the balance, okay? Cosine integrates to sine. And then you plug in a 4, and you plug in a 0, and that puts you to here. And then you do a little bit of arithmetic. I just cross-canceled right there, right? 6 over 2 is 3. And that's the answer. All right.